Welcome to Curio Flow Talk, the show that feeds your curiosity.
That's right.
And today, we're diving deep into something really cool.
Yeah, it's pretty amazing stuff.
Quantum computing.
It sounds like science fiction.
It really does, but it's becoming more real every day.
It is. It's getting closer all the time.
Now, I know quantum computing can sound intimidating, but don't worry.
Oh, yeah.
We're going to break it down.
Yeah, we'll make it easy to understand.
Simple enough that even a 10-year-old could get it.
Exactly.
And to help us do that, we have an expert here who eats, sleeps, and breathes quantum computing.
Well, I try to get some sleep in there, too.
So let's dive in. What exactly is quantum computing?
Well, it's a whole new way of thinking about computers.
Okay, how so?
It's not just about speed, it's really a different kind of beast.
A different beast.
Yeah, they operate on these bizarre rules.
Bizarre. How?
The rules of quantum mechanics, the stuff that governs the really tiny particles in the universe.
Well, I see.
And that lets them solve problems that would just leave regular computers, even supercomputers, completely stumped.
Okay, so let's back up a bit. What makes a computer quantum? What's the big difference?
Think about it this way. Regular computers, the ones we use every day, use bits.
Right. Bits, the zeros and ones.
Exactly. It's like a tiny switch that's either on or off, a 1 or a 0. But quantum computers use qubits.
Qubits.
Yeah, and these are much weirder. Imagine a coin spinning in the air.
Okay, got it.
It's not heads or tails until it lands.
Yeah, it's kind of both at the same time until you stop it.
Exactly. And a qubit is kind of like that. It can be both a 0 and a 1 at the same time.
Wow, that's mind-bending.
It's called superposition, and it's one of the things that makes quantum computers so powerful.
So it's like the computer is running multiple calculations at once with every qubit.
You got it.
No wonder they're so powerful.
And there's another thing, too. It's called entanglement.
Entanglement sounds complicated.
It's a bit spooky, actually. It's where two qubits get linked together. Yeah, their fates are intertwined, even if they're miles apart.
Okay, now you're really losing me.
So let's say you measure one qubit, and it turns out to be a 0. Boom. You instantly know its entangled partner is a 1, no matter how far away it is.
So they're like connected, like telepathically or something.
That's a good way to think about it.
Okay, so we've got these qubits doing their quantum dance, existing in multiple states at once.
Right.
But how does that actually translate into real-world applications?
Imagine you're trying to solve a maze.
Okay, I can picture that.
A classical computer tries each path one at a time. But a quantum computer, thanks to superposition, it explores every path simultaneously.
Wow, that's efficient.
Exactly. It makes them incredibly good at solving certain types of problems that would take a classical computer an eternity.
So they're not just faster. It's like they're approaching the problem in a whole new way.
Exactly.
Are there any examples of this quantum speed advantage in action, like real-world stuff?
Oh, absolutely. A few years back, Google made headlines. They had this processor called Sycamore.
Sycamore?
Yeah, and it achieved something called quantum supremacy.
Quantum supremacy sounds impressive.
They basically set up a problem very specific to highlight the strengths of quantum computing. And Sycamore solved it in minutes, while it would have taken a supercomputer like thousands of years.
Thousands of years. That's insane.
It is. It was like comparing a horse and buggy to a supersonic jet.
So it's not just theory anymore. Quantum computers can actually do real calculations.
Exactly. And that was just the start. Since then, companies like IBM have been building even more powerful quantum computers.
Really?
And they're offering cloud access to them.
So like one day I could be running a quantum program on my laptop.
That's the idea. Researchers, companies, they can all experiment with these cutting-edge machines.
That's wild. It really opens up some possibilities.
It does, and that's not all. Researchers at Oxford University, they've made a breakthrough in something called blind quantum computing.
Blind quantum computing. What's that?
It adds a whole new level of security to the game. Basically, you can run computations on a remote quantum computer without revealing your algorithms or your data.
So it's like super secure.
Super secure. Even the quantum computer itself doesn't know what you're doing.
That's amazing, especially as quantum computing starts being used for things like finance and healthcare, where security is paramount.
It is. It's a game changer.
So we've got these incredibly powerful quantum computers becoming more accessible. We've got this amazing security with blind quantum computing. Where does this all lead? What's the real-world impact of this quantum revolution?
Well, the potential is huge. It's not just one industry. We're talking about revolutionizing medicine, finance, materials science, even astronomy.
Okay, now you've got me really intrigued. Let's dive into those specific applications. But first, a quick word from our sponsors. Don't go anywhere. We'll be right back to explore the mind-blowing potential of quantum computing right here on CurioFlow Talk. Welcome back to CurioFlow Talk. Before the break, we were talking about how quantum computing could revolutionize different industries, like medicine, for example.
Yeah, that's a big one.
What kind of impact could we see there?
Imagine designing drugs, but like specifically for your DNA.
Whoa, personalized medicine.
Exactly. Or treatments based on like a really deep understanding of how diseases work at the molecular level.
That's amazing. But how would quantum computers actually do that?
Well, they're really good at simulating things.
Simulating.
Yeah, complex systems, like the interactions between molecules in our bodies.
Okay.
That kind of stuff is really hard for regular computers to handle.
Why is that?
Well, as the system gets more complex, the number of calculations just explodes.
Ah, I see. Too much for a classical computer to handle.
Exactly. But a quantum computer, it can explore all these possibilities at the same time, remember? Superposition.
Right, right. So it can handle those simulations way easier.
Exactly.
So we could develop, like, super targeted therapies.
Yeah, for diseases like cancer, Alzheimer's, you name it.
And that would mean fewer side effects, better results.
You got it. And it's not just about new drugs either. We could understand existing drugs better too.
Oh, how so?
Figure out the best dosages, the best treatment plans.
That's huge. So quantum computing could really change healthcare as we know it.
Absolutely.
What about other fields? You mentioned finance earlier.
Oh yeah, finance is ripe for disruption.
How so?
Think about all the algorithms they use for financial modeling.
Okay, yeah.
Quantum computers could take those algorithms to a whole new level.
Really?
Yeah, more accurate risk assessments, better portfolio management, maybe even completely new financial instruments we haven't even thought of yet.
So it's like quantum-powered investing.
In a way, yeah. Making smarter decisions, managing risk more effectively.
And probably making a lot of money for some people.
Maybe. But there are other benefits too.
Like what?
Fraud detection, cybersecurity, protecting financial transactions and sensitive data.
So quantum computers could make finance safer too.
Exactly. It's a pretty big deal.
It sounds like it. Okay, let's move on to materials science. I've heard some buzz about quantum computers designing new materials.
Oh, yeah, that's one of the most exciting areas.
What kind of stuff are we talking about?
We could design materials with specific properties.
Like what? Give me an example.
Imagine a room temperature superconductor.
A what?
A material that conducts electricity with zero resistance.
No way is that even possible.
It's theoretically possible, and quantum computers could help us figure out how to make it a reality.
And what would that mean?
Think about energy transmission. It would be incredibly efficient. No more energy loss during transport.
That would be revolutionary.
It would. And we could design other materials too. Super strong but lightweight materials.
For what?
Lighter cars, more fuel-efficient vehicles, buildings that are resistant to earthquakes.
So we could basically build a better world with these quantum design materials.
We could. It's pretty amazing to think about.
It is. Okay, last but not least, let's talk about astronomy. You mentioned that earlier.
Oh yeah, astronomy could be totally transformed by quantum computing.
How so?
Well, telescopes collect massive amounts of data.
Right.
Quantum computers could process that data way faster, way more efficiently.
So we could analyze, like, celestial objects and events better.
Exactly, with way more precision.
And that means?
Maybe we discover new planets, new galaxies, maybe even things we haven't even imagined yet.
It's mind-blowing to think about.
Yeah.
We could unlock the secrets of the universe with quantum computing.
We could.
But with all this potential, there must be some challenges too, right?
Yeah.
Can't all be sunshine and roses.
Of course. There are definitely hurdles to overcome.
What kind of hurdles?
Well, one of the biggest is something called quantum decoherence.
Decoherence. That sounds ominous.
It's a bit of a problem. Basically, qubits are very sensitive
Sensitive to what?
to their environment. Any little disturbance, like heat, vibration, electromagnetic fields, it can mess them up.
Mess them up how?
They lose their quantum state. They decohere. And that means they can't do their quantum magic anymore.
So it's like they get distracted.
Kind of, yeah.
Yeah.
Like trying to build a house of cards in a windstorm.
Oh, I see. It's a very delicate process.
It is, but researchers are working on ways to make qubits more robust, less prone to decoherence.
That's good. Any other challenges?
Scalability is a big one.
Scalability.
Building quantum computers with lots of qubits and making them all work together reliably, that's a huge engineering challenge.
So while we've seen some amazing progress, like with Google Sycamore, We're still a ways off from having quantum computers that can tackle really big problems.
That's right, but the progress is happening fast.
That's good to hear. So while there are still challenges, the future of quantum computing is bright.
It is.
But I'm curious about something else. What about the ethical implications of all this?
Yeah, yes, the elephant in the room. It's definitely something we need to think about carefully.
Yeah, it's like we've been focusing on the good stuff, but we can't ignore the potential downsides.
Right,
It's
exactly.
like any powerful technology.
Yeah,
Quantum computing could be used for good or for bad.
it's a double-edged sword, that's for sure.
So what are some of the risks we should be thinking about?
Well, one big one is the potential for misuse. I mean, the same power that can help us discover new drugs could also be used to design bioweapons.
That's scary.
Yeah, it's a serious concern. And then there's the impact on cybersecurity.
Oh, right. What happens when quantum computers can crack all our encryption?
That's a real possibility. A lot of experts think that quantum computers will eventually be able to break the encryption we use today for like everything.
Like online banking, government secrets, everything.
Pretty much.
So what can we do about it?
Well, there's a lot of research going on right now to develop new encryption methods, ones that are quantum resistant.
So it's like a race against time.
It is. We got to stay one step ahead of the bad guys.
And beyond those specific risks, there are those bigger societal questions too.
Right, like what happens to jobs when quantum computers can do the work of humans?
So it's a valid concern.
It is. We need to start thinking about those things now and figure out how to manage the transition.
It's a big responsibility, not just for scientists and engineers, but for policymakers and business leaders too,
Absolutely. We need to work together to make sure quantum computing is used for good.
to make the world a better place.
Exactly.
Well said. So we've covered a lot of ground today, from the mind-bending basics of quantum mechanics to the potential risks and ethical dilemmas.
Yeah, it's been quite a journey.
But one thing's for sure, quantum computing is a game changer. It has the potential to revolutionize pretty much every aspect of our lives.
And we're just scratching the surface. Who knows what amazing discoveries and applications are waiting for us in the quantum future?
It's an exciting time to be alive, that's for sure. Well, that's all the time we have for today. But before we go, we want to hear from you. What excites you the most about quantum computing? Let us know in the comments, and maybe we'll feature some of your thoughts in a future episode. Until then, stay curious and keep exploring. This is CurioFlow Talk, signing off.